Hello, hello. Looks like everything's set up okay. Just gonna have a quick double check with a few of the setup bits. That's fine, that's fine. Cool, right. So I think plan today is continue on where we left off with our endless runner. We're currently following this tutorial from Practical Programming, I think it was called. Yeah, Practical Programming. On creating an endless runner in Unity. Let's just double check a few bits here. That's okay. And that's going to go to that. Right. So where we got up to yesterday is we spawned in our player object, and we've got the ground tiles spawning around the player. So as you move forward, the tiles behind you are removed. If we zoom in a little bit here, you can probably see a bit better. So the tiles behind the player are removed and new tiles are added in front of the player. And then over time, the player speeds up with the ground matching. And you can control the player left and right, and there is a jump function. And this also works on a controller. And we made it so that the removal of old tiles occurs based on the movement speed of the player, so you don't end up with more entities being generated. There is now a max speed, which I believe we are probably at here, which should be 450. It goes up to. Oh no, we're not quite there yet. So there we go. We've hit our max speed of the player now. So as you can see, tiles should be being deleted roughly as quickly as they're being generated. There's maybe a few extras popping in. And we've also coded in a reset. So if you press escape or if you press start on the controller, it clears the old tiles and recreates the starting scene. Hey, iBrett. Is it iBrett? How's it going? Welcome in. So we got to this point yesterday. We were trying to figure out with the reset mechanic of how to move the player back and respawn all the starting tiles, which I think we've got to. And yeah, so the next steps will be adding obstacles into the endless runner. So we're going to pause the game for the moment. And we're following along with this tutorial from Practical Programming. Let me just put this curtain so I can see without glare. I have a YouTube channel, but I wouldn't really say I'm a YouTuber. I'm just starting on learning how to use Unity. As of, I think the first Unity stream was like Friday last week. So learning all of that. Kind of new to streaming as well. Oh, no, that's the wrong part to change. Been streaming this year basically, so since I think the first or second week in January. And I do a couple of Dead by Daylight streams a week, a Cuphead stream, and then I'm starting to pull in some Unity streams to get me started on a game dev course. So if any of those sound like they're of interest, feel free to stick around. Hope you enjoy them. But yeah, there are links to my live YouTube channel in the panels, I think, or in the description in Twitch. And then there's a second YouTube channel that I want to start editing clips into and having them as like edited videos. So if you don't want to watch the full live streams or stuff like that on YouTube, hopefully those will be easier to get into. But yeah, I think I'm also learning how to use DaVinci Resolve, so that there'll be a few more weeks before I start doing edited videos, I reckon. Right. Let's follow along with this guy.
Let's get started. The first thing I'm going to do is go to our prefabs folder and open up the ground tile by double clicking on it. I'll right click and create a new empty game object, which I'll press F2 to rename and call it the obstacle spawn left. I'll say its position on the X to -3.3, position on the Y to 0.5 so that the obstacle stands on the ground, and its position on the Z to 10 to move it to the very back of the tile. I'll duplicate this twice using Ctrl D and call them obstacle spawn middle and obstacle spawn right.
Okay, let's put these in. So we're just putting in, I'm guessing these are spawning points that we're putting in into the
obstacle stand on the ground, and its position on the Z to 10 to move it to the very back of the tile. I'll duplicate this twice using Ctrl so you don't miss another video. Without further ado, let's get started. The first thing I'm going to do is go to our prefabs folder and open up the ground tile by double clicking on it.
Yeah, sure. You made a game for a game jam. Which game jam was it? I don't think you'll be able to post links in chat because I think I'm using Stream Elements and I think the auto mod removes links. But if you wanna, what's going to be the easiest way? I think if you can whisper in Twitch, or if you just tell me what to search for, can have a look. What a glare. Let me just quickly fix the glare on my screen so I can actually see what's on it. Back in one minute. The game jam's name is Megara, or hopefully that's pronounced right. Sorry, that's not. You can see I've got some sunlight. Nice. It's a Turkish jam. Oh, cool. What was your game called? Let's translate the page. Go to jam area. Oh, it's a login. Maybe I want to go to the itch.io page. 400 entries, right. Yeah, unfortunately you won't be able to post links, but if you can tell me the name, then I can search for it, I think. Maybe. Submissions, there we go. Baton owner. We can translate. Let's yeah, let's have a quick look. How do I play? Can you play in window? Or do you have to download it? I'm guessing go for the After Jam Edition version. So A and D is horizontal movement, and space to jump, and X is wand. The Cave Jam contains bugs and glitches. The project that continued to be developed after Cave Jam ended, certain bugs have been fixed. No worries. Thanks for dropping in. Hopefully see you later. We'll give that gaming a little try later. Right. So we're going to spawn in. Let's go back to normal. Yeah. See you later. Have a good one.
Its position on the X to -3.3, position on the Y to 0.5 so that the obstacle stands on the ground, and its position on the Z to 10 to move to the very back of the tile. I'll duplicate this twice using Ctrl D and call them obstacle spawn middle.
Yeah, when we look here,
spawn right.
We've got a left, and then
For the middle one,
twice.
set its position on the X to 0.
No, we'll call this one middle.
Its position on the X to 3.3.
We'll call this one right.
Next, I'll exit out of the ground tile prefab by hitting the back button over here. Then right click in the hierarchy and create a new cube, so 3D object cube. I'll press F2 and call this obstacle. I'll right click on the transform component and hit reset. Then I'll set its position on the Y to 0.5. and its scale on the Z to 10/3, meaning that will take up to 0.
Right. Did you make it? Made a cube. Okay.
And hit reset. Then I'll set its position on the Y to 0.5, and its scale on the Z to 10/3, meaning that will take up exactly 1/3 of the width of our ground tile. This will be important in the future.
So we're at Y 0.5. And brick scale 3/10, and then 1 on 1. That always did. Check I didn't miss anything there.
To 10, I click on the hierarchy and create a new cube, so 3D object cube. I'll press F2 and call this obstacle. I'll right click on the transform component and hit reset. Then I'll set its position on the Y to 0.5, and its scale on the Z to 10/3, meaning that it will take up exactly 1/3 of the width of our ground tile. This will be important in the future if we want to have some tiles spawn multiple obstacles so that they line up seamlessly. Finally, I'll drag it into our prefabs folder to turn it into a prefab, then delete it from our scene.
Okay.
With that done, we can now go to the script folder and double click on our ground tile to open it up in Visual Studio. Once it opens up, go down to the bottom and add a new variable, which will be public game object obstacle prefab.
Okay, public game object.
This creates a variable
Alright,
type of game object called obstacle prefab, which is accessible from anywhere, including the inspector. To check this, let's quickly go back to the editor and assign our obstacle prefab to the ground tile. To do this, I'll go to the prefabs folder and open up the
this, we
ground
go
tile.
here.
And And then under the ground tile script, you'll see a slot for the obstacle prefab. I'll drag and drop the obstacle prefab that we just made into there. With that done, we can now return back to our code. I'll drag and drop the obstacle prefab that we just made into there.
So we've got ground.
With that done, we can now return back to our code.
Spawner.
We're going to create a function for spawning obstacles. So to do that, type void spawn obstacle. Open and close some parentheses.
Wait 1 second. Where? So we should have our prefab here, right? Obstacle prefab. In the ground tile spawner. Let's have a quick double check. Oh, in the prefab. Okay, we go to the prefab. And then in here, there we go. Right, then we drag that in. And then we can go back. And we're here.
Open up the ground tile. And then under the ground tile script, you'll see a slot for the obstacle prefab. I'll drag and drop the obstacle. To do that, type void spawn obstacle. Open and close some parentheses, and then some curly braces. Inside the curly braces, we're going to need to choose a random point to spawn the obstacle.
Okay.
Then we'll spawn the obstacle at that position.
So,
Random point. All we have to do is select one of the 3 spawn point game objects that we created at the start of this video. If we return back to the editor, we can see that they range from the 3rd to the 5th child object. But remember, we start counting from 0, so the plane would be 0, the next spawn point 1, so that means that the first obstacle spawn point is the 2nd child, and the last one is the 4th child. With that in mind, let's go back to the script.
transform fit child.
For integer, obstacle spawn index is equal to random dot range, and then
Obstacle
we're going to give it 2
spawn index.
The reason why we're using 5 as the last number is this function gives us a random number between the 2 inputs,
Random dot
including
range.
the first one, but excluding the last one.
2 to 5. Okay.
Don't ask me why, but that's just the way it is. So with a random number between 2 and 4 inclusive, we can now say transform spawn point is equal to transform to get the transform of this component dot get child, and then we give it our obstacle spawn index. This returns a game object, but we specified a transform here. So to get the transform component of that child, I'm going to add dot transform at the end. That simply returns this transform component of any of these 3 obstacle spawn points.
So the position relative to...
To spawn the obstacle, all we have to say is instantiate, which is Unity's fancy way of saying spawn, then give it the obstacle prefab as the object to spawn point, dot position as the position to spawn it, quaternion dot identity as its rotation. This means
which is no rotation,
And finally transform to set its parent. Remember, transform simply means this object's transform. So when the ground tile is destroyed, the obstacle will be destroyed along with it. This prevents a build-up of thousands of obstacles in the level if tiles are being destroyed, but some obstacles are not. If you don't understand any of what I just said, don't worry about it, as you'll understand it once we start testing the game.
Yeah, that's fine.
Finally, in the start function, near the top, we'll call this function by typing spawn obstacle and with parentheses. Now we can go back to the editor, just give it a moment to load. Then I'll make the game view a little bit bigger and hit play to test it out.
Yeah, I don't think we need to worry too much about that.
Obstacles are spawning, that's great. But the player seems to be moving a bit too slowly for me. So I'm going to go to the hierarchy, exit the ground tile, and select our player. in here, I'll increase its speed to maybe something like 10, and its horizontal multiplier.
Okay, let's
1.7.
give it a little go.
Now, if I click back into the game view, this is moving at a much better
So we're gonna
speed.
save it. We're gonna click play.
Let it play, and make sure I put those.
I don't think we put any collision on this, but okay.
As anything you edit during play mode.
And then we can jump over these.
You will also have noticed that when we hit an obstacle, nothing happens. To fix this, let's go to our scripts folder.
Oh, do we just get slowed down going through obstacles?
Go to create C# script, and I'll call this.
It seems to get moved a little bit as well.
Give it a moment to compile, and once that's done, double click to open it up in Visual Studio. We're going to need one variable, type of player movement.
God, this is gonna be so. This is too fast at this
I'll
point.
call this player movement with a lowercase p.
With the amount of obstacles being
In the
spawned.
start function, let's set player movement.
I think the issue is that every single tile is getting an object spawned as well. Right. Oh, no, didn't want that.
Type.
I want to create a new
Inside
script.
angular
Cool.
brackets, I'll type player
Obstacle.
movement, then end it with parentheses and a
Obstacle.
semicolon. This looks for an object of the type player
We can
movement.
close this.
Remember, this is attached to our player, and sets the variable equal to that.
Right, so a couple of things I think we want to do here is, one, we want to make it so that it doesn't always spawn a new obstacle. And two, I think we want to do it so that it's so that it can spawn multiple obstacles as well. So on each tile you could have 1, 2, or no, 0, 1, or 2 obstacles. But make it rarer and rarer as well. Wait, let's just refresh this.
Hi guys, and welcome to the third video in the series on making a 3D lens runner Unity. In this
No,
video,
not what I wanted to do. Give me a second. Let's do this. I'm gonna swap over here to this. Oh, okay, now I want to refresh. We should be on the right account.
Hi guys, and welcome to the third video in the series on making a 3D array from the third to the fifth tile object. Transform
Cool.
of this component dot get title, and then we get the obstacle spawn points.
Right, okay, so what we want to do here is swap some code over. So we want to make it so that sometimes it spawns. So rather than random range here, I think if we want to do, int randomized random number. What's a better term for this? Actually, I'm guessing this is scoped within the spawn obstacle function, so we don't need to worry too much about unique naming. So random number here is fine. So equals random start range. So I'm guessing min inclusive max. See, it says min inclusive, max inclusive, range is inclusive. But our guy at Practical Programming said it's excluding the top range. I think what we want to do is we want to do random number from 1 to 100, let's say, and I want to log what that number is. Random number, and then we want an if statement here. So if random number is, let's say, less than 20, so it should give us 1 to 19. Let's do range 0 to 100. So that'll give us 0 to 19, so give us 20 options. then obstacle spawn index. I think really what we want to do is here is we just want to instantiate this and here do this, get child 2. Right, we're going to instantiate this here, and don't do it there, don't do it there. Now this is going to be messy code to start with, but we will tidy it up later. The else random number, I know we could probably do a switch here rather than if else statements, but I'm going to stick with this for the moment, and then we'll change it up again later if we need to. So else if less than 40, so we get the values of 20 to 39 here. We're going to do these two again, but this is child 3. Now, what was he saying? It was from the prefabs, we're at ground tile, so we have 0, 1, 2, 3, 4 are the ones we're looking for here. Then else random less than 60. We're gonna do our spawn child 3, spawn child 4, sorry, and then sorry, it's else if, isn't it? Yep. Else if, then else if again. Now we're going to say random number less than 70. We spawn 2 objects. No, we want to do 2 of these. Let's say this will be our transform. Okay, so we do the 2 side objects. Really what we want is, actually let's do this now. Let's do a void. So this isn't spawn obstacle. This is let's call this for random obstacles. And in here we have a void spawn obstacle, which we're going to take an int of the child position for the obstacle, and what we're going to do is we're going to do this, and this is the child position, and actually the transform spawn point can just be in here. Actually, it doesn't need to be. Can it be in? If we put this within here, then it can be a method of this obstacle, right? Yeah, that's better. So we don't want this to be able to be called outside of our function. So then we can move this up here, and then we're only using one variable here, and we're just reassigning it each time. Whereas if the transform was inside this, then it might be creating new classes each time. Transform class. So instead of this, we're going to do all of this is replaced by spawn obstacle 2. Nice. That's much nicer. So that's going to be 3, that's going to be 4, this is going to be 2 and 4. 2, 3, 4. It'll be 2 and 4. And we'll do another couple of these. So it's less than 80. We're going to spawn 2 and 3. Actually, let's do this normally. 2 and 3, 2 and 4. 3 and 4. Less than 90. And then else we're just going to do nothing. Which we don't actually need. It'll automatically do that. Right, we save that, it'll redo the formatting. Okay, so we've got less than 20, it'll be a 2. Less than 40, so 2 is left, 3 is middle, 4 is right. Less than 70, it does both of them, 2 and 3. Less than 80, it does 2 and 4, and less than 90, it does 3 and 4. Let's have a look what that looks like. So it's slightly weighted to spawn single object, but everything else is actually, yeah, it's double chance to spawn a single object in a certain position. Yeah, so a tenth of the tiles should have no object. A tenth will be middle left, a tenth will be middle right, and a tenth will be both outer edges. New spawn object. Oh yeah, wait, we didn't spawn random object because we renamed it. Obstacles even. So that should be okay now. And we might have to have a look again at the script of this ground tile. No, that's fine. Right, let's have a look, see what that does, see if that worked as we expected. That looks a bit better. So yeah, it's randomizing where it spawns. Sometimes spawning 2, sometimes spawning none. And it looks like the distribution is about right. Spawning 2. Oh. Oh, you can double jump, can't you? Okay, we're gonna have to spawn tiles a bit further in front when we're going faster. And yeah, this max speed is just ridiculously high. I'm not gonna need anything like this. I don't think we're even near the max speed, are we? Okay, that's the max speed. There's no way anyone can react to that kind of stuff, so we'll bring the max speed way, way down. So we were in play movement for max speed, isn't it? Up here, right. So let's say if the speed is over 100, we'll cap it. 100. So if it's max speed, we're not even counting up at all, or counting down at all. Let's see how fast 100 is. I think 100 is still going to be too fast, but worth trying out. Okay, I think we need to make the jump a bit more responsive as well. not as floaty. And we need to make it so you can't continually jump as well. There's only one jump when you're on the ground for this game. Keep it a bit simpler. Ah, if I jump out of the collider, then it doesn't despawn. It's interesting to see that we get stopped here. But at faster speeds, we just go straight through. What's our speed at the moment? On the player, speed is 5. We might have found a bug. We're not getting sped up. Can we reset it? Is it still okay? Yeah, it's not counting anymore. If not max speed. Have we not reset it on? We don't reset max speed false. There we go. Good test here. Right, now if we restart. We might have to stop and restart. We'll have a little look. So last time it's because we reached our max speed. So let's leave it here for a second and see what happens. Now I think we're also... Yeah, see look, it's starting to push through the... I wonder why it pushes through the collider. I bet it's because our plane movement is just repositioning, yeah? So when we're moving forward, we're just jumping forward based on whatever the distance move forward is. Okay, that'll be something to have a look at. So really, we're not colliding here at all. We might be colliding for a frame. But if we jump forward, we're jumping past the obstacle, so we don't have to worry about it. Okay, let's have a look what's next.
To spawn the obstacle, all we have to say is instantiate, which is Unity's fancy way of saying spawn. Then give it the obstacle prefab as the object to spawn, spawn point, dot position as the position to spawn it, quaternion, dot identity as its rotation, this means it will have no rotation, and finally transform to set its parent. Remember, transform simply means this object's transform, so when the grand tile is destroyed, the obstacle will be destroyed along with it. This prevents the build-up of thousands of obstacles in the level if tiles are being destroyed, but their obstacles are not. If you don't understand any of what I just said, don't worry about it, as you'll understand it once we start testing the game. Finally, in the start function, near the top, we'll call this function by typing spawn obstacle and with parentheses. Now we can go back to the editor, let's give it a moment to load. And I'll make the game view a little bit bigger and hit play to test it out. The obstacles are spawning, that's great, but the plane seems to be moving a bit too slowly for me, so I'm going to go to hierarchy, exit the ground tile, and select our player. In here, I'll increase its speed to maybe something like 10, and its horizontal multiplier to maybe 1.7. Now if I get back into the game view, this is moving at a much better speed for me. I'll exit play and make sure I put those values back into the plane movement script, as anything you edit during play mode will not save. You will also have noticed that when we hit an obstacle, nothing happens. To fix this, let's go to our scripts folder, right click, go to C# script, and I'll call this obstacle. Give it a moment to compile, and once that's done, double click to open it up in Visual Studio. We're going to need one variable, type of player movement, and I'll call this player movement with a lowercase p. In the start function, let's set player movement equal to game object dot find object of type, and inside angular brackets I'll type player movement, then end it with parentheses and a semicolon. This looks for an object of the type player movement. Remember, this is attached to our player, and sets the variable equal to that. Next, I'll create a new function, which will be void on collision enter. This function is called automatically when two objects collide. In here, we want to kill the player. To kill the player, let's go back to the player movement script, so I'll go to the editor. Then double click on our player movement script. Top, I'll add a new variable. This will be type of boolean, so bool, and I'll call this alive. By default, I'll set its value to true. At the top of the fixed update function, I'll add a line saying if not, so bool, and I'll call this alive, when two objects collide. In here, we want to kill.
Go back to normal speed here for the moment. Okay, so find object of type player movement, and then it's a function, that's why. Cool. And then we want a private void, not there, private void on collision enter. Collision, oh. Automatically fills that in. I've got to remember that like a few times now. Collision. Right.
Kill the player. To kill the player, let's go back to the player movement script. So I'll go to the editor. Then double click on our player movement script. Top, I'll add a new variable. This will be type of boolean, so bool, and I'll call this alive.
I think what we want to do is when we restart, we leave ourselves stopped for a couple of seconds. So what I want to do here is make an int countdown. Let's do start countdown. And we'll set that to 5 for the moment. It's not 5 seconds though, is it? I wonder how. Let's see, how do we do a delay? Delay 5 seconds. C# Unity. Use wait for seconds. Okay, let's have a look at this wait for seconds script. Yield on a new, wait for 5 seconds. Okay, let's do a. Now, do we want this in our function? I think we want this in our function. So let's do yield, return, new, wait for seconds, 5. And then before our wait, we want to set our speed to 0. Speed up interval to speed up multiplier we want as 1 to start with. We want to do all of this. Then we wait, and then we start moving. Right, let's why is this? Cannot be an iterator block because void is not an iterator. It doesn't like this in our iterator. So I think we want a separate I enumerator. Let's call this wait. And we'll just do this in here. Enumerator could not be found. So I'm guessing that's in our system collections here. Yep. So then here we just do our wait. And actually let's pass in the int number of seconds. Int number of seconds. And then we put this in here. Right, let's see how that works. Okay, we'll let these load. Right, and then as we run this, I didn't see we had a no. We definitely got not getting our wait for 5 seconds there. We need to call it as a coroutine. Maybe. Let's try that. Oh, start and restart. Stop and restart even. Nope. Right. So this doesn't seem to be working. Glass, wait a second. For example, look like. It's the same function, but within a numerator rather than a... Hmm. Coroutine is a method you declare with an I enumerator return type with a yield result. Set a coroutine running. You need to start coroutine function. Yeah, so what we should be seeing here is our speed here should be 0. And we should be seeing here what was the way that they were doing it here? Yeah, let's put this in. This, and then let's have a pre-stop here plus speed, and let's call this post stop. Let's just see if that's doing anything at all. I've got a feeling it isn't. Ah. So it is starting and stopping, but it's not actually holding the rest of the function. Let's just wait for fixed update do. Coroutine time delay, right? By default, you Seat resumes. A coroutine on the frame after a yield statement. Started plus number of seconds. Oh. Delay 2. Kerosene at time start. Okay. Let's do that. Sorry, links are disabled. Get rid of that. I'm assuming that's a bot account, right? Where were we? We're having a look at analysing coroutines. Pressure. Update on late update callback. This is useful if you have long running or infinitely looping coroutines. Okay, not necessary for that. Okay, we don't need to look at that just yet. I think that's for another day. So we're going to pause that. We're going to pause this stuff. I think this is all the right order. So setting our speed to 0, going back to the start, and then starting again. We could have the initial speed a bit different, but that's fine. Let's take this. Where we are spawning our obstacles here, I just want to debug if we're on 0. If we get 100. So I just want to check if that occurs. Actually, we can cheat this. So rather than that, what I want to do is be 0 to 1, and that should always be 0, right? There should be an int, min inclusive. Oh, it says min inclusive, max exclusive this time. I swear it said inclusive on both. No, okay. So I don't need to do that. I think actually if we just make the jump less force, so we just do like a 2F jump, That might feel like a better level. Oh, that's way too small. Maybe someone at 5 or 6. That might be better. Right, so is that enough to jump over? Just about. I would quite like a less floaty jump though. So I wonder if I can give my player character a bit more of a heavier mass. Then we could do like a slightly higher jump than this, but it should come down quicker. Oh yeah, and we've got to get rid of the double jump option. Okay, let's pause that for the moment. Right, let's get rid of the double jump. So, so we want to check the player rigid body dot position dot y is less than what are we starting at? We are, our player starts at 1. So we say, let's say if it's less than 1.2, then we can jump. That should stop us double jumping it in the air. Cool. Yeah, so you can't double jump in the air. But what you might be able to do is actually, if you spam the jump button while you're low enough, you can queue up some multiple jumps. Go. No, it's pretty difficult. Okay. Right, I want a slightly higher jump, but I want a cooler, a harsher pull. So, how do I make jumps less lacy? Actually, can I also delete this message? Yes, cool. Right, so Unity, less floaty jump. Code works, but the jump feels floaty. Make gravity greater? No. I feel like if we leave gravity at 9.8, that should work, right? Yeah, for a really fast jump, you want jumping on max full speed. American use you try to use more realistic proportions to make your character 1.8 meters taller. Yeah, where's the weight though? So set weights are object unity. Weights mass times gravity. So you should never set the mass higher to 10. Unit of mass in kilograms. The weight would be. Yeah, okay. So what's the scale on. Let's see, we've got our rigid body here, mass. Now, is this mass in... What's the units of? Unity mass unit. I think 1 unit is 1,000 kilos. No way. It's in kilograms, right, okay. Mass of the object in kilos, okay. Right, so if we make this like 80, does that mean we're going to fall quicker? Oh, we can't even jump now. Because that force isn't enough for a jump. Okay. Where's the start? Maybe we want to put a jump force in here. Does this have to be a float? What if I just times it by 6? Does it? Yeah, okay, that's fine. So let's do our public float. No, public int is what we want. Public int, jump string. And who knows, maybe 120 is good. So we'll start with that. And we need to use it in here. We should probably have it in its own separate section. So it's, well, we'll figure that stuff out later. Right, so when we press play, we now got a jump of 120. God, that barely moves. Well, okay, I'm guessing actually if we've got our weight, so our player mass is 80. So if we're doing an impulse force, I think it says. So this is calculating a force. So this is 120 up. That's going to be too small, right? We run our calculator. So we've got 80 times 9.8. That's our downward force. So to counteract that, we might be having to look at like thousands. Level around that, maybe. Okay. So now, that's still not enough. That's only just counteracting it, isn't it? So if we up the Oh, did I not save it? I did save it. Let's restart it. Initial jump strength is 1000. We're not using it anywhere else, are we? No, just where we're combining it in with jump. I don't think that updated properly. Let's just overwrite it here. And see what we get. Still feels very flighty. That's a bit too high of a jump as well. Okay, so we can cut it down here. So 700. What does that look like? Yeah, the jumps are always a bit floaty. Right, let's have a look for how to make this less floaty. Oh, is it because, yeah, because our height isn't the height of a person, right? So we're really like 1.8 meters tall. We probably want to bulk those out a little bit. So then our starting Y is it 1.8? Let's see if this feels like a normal jump. We can't jump now. Why can't we jump? Because our Y value is too high. We said we can jump when we're almost to the ground. So less than 2 now. Good work. Let's just see if this feels less floaty. Obviously, if we change the scale of this. No, it's still the same. I mean, to be fair, most people can't jump that high, so... Let's bring this way down. Even lower. What if it's like 400? No, you don't get any air at all there. No, okay, I think what we need to do is we'll go back to our height of 1 and these a little bit smaller. We'll put our jump strength down. Let's go with 500 to start with. And save that. So how can we adjust our gravity a little bit? Don't need that. Don't need... We'll come back to that one. I think we're mostly happy with how we're doing the inputs now. So we'll close that for the moment. We can always come back to these. Right, so change gravity unity. Okay, so it's in the collections. Physics of gravity. Now in reality, we can change it globally, right? Edit project settings, time. Okay, global things like physics, which seconds, yeah. Yeah, I don't... I think weight doesn't affect falling speed. Things like inertia, yeah. Up in gravity. No, I think we want to go for... And this Spotify goes... There we go. So far... No, edit. Project settings. Physics... Well, it's not TDI. Okay, and if we double this to like 20, let's see. I think that saves automatically, doesn't it? What happens if we play this now? We might need to up our. See, that feels much nicer. Way less floaty. We need to up our jump possibility as well though. So rather than 500, let's go back up to 1,000. See what that looks like. Bit too much. Maybe 750. Is that enough to get over an obstacle? It is just about. Okay, let's do our speed up multiplier down to 1.1 instead of 1.2. And then the interval, reset this. Oh no, this needs to be 1.1. This needs to be... So at the moment that's every 5 seconds. So let's just do every 50 seconds. Or let's go to every 25 seconds for the moment. Let's see if this kind of thing feels a bit nicer. Yeah, and then we did the jump strength up to 750, didn't we? That feels a little bit better. We might be able to speed up a bit quicker than this though, because this will just be boring for players to start with. Maybe we want an additive speed up rather than a multiplier. I think that might be better. Because the multiplier, you get faster and faster way quicker. We still need to do the collision with the obstacles properly. But starting to get something that looks a bit like a game. Cool. Right, so reset these values. So that's 750, 1.1, speed up interval, 600. Yeah, that's not going to be what we're going to go with. Let's go with plus speed change. Let's do speed change. Actually, let's just rename symbol. So then it changes it everywhere. Let's put this in the right order. So this is 750, this is 1.1, this is 600, and it's now initial speed speed change rather than speed multiplier. So we're starting at 5. Let's say we add, let's see what adding 10 does each iteration. That might be too much, but we can play around with those settings. So why is this not updating? Initial speed. Oh, because we didn't change this properly. Let's go back. We do 2. Change. Enter. Renames it. And then this is now 10. We save that. Now this should change, right? Yeah, cool. That's done, that's done. Let's see what adding 10 meters per second every... We're speed 5 at the moment. And when that speed up interval here goes down to 0, I think it's visible, isn't it? Yeah. And we go up to 15. That's a little bit of a jump, but not too bad. Bit too much. And our speed up interval is not being set properly, so we've got it at 600 here. That's why. These need to be private. Speed change, private vector, private speed. Oh, it's public so I can see it, isn't it? Private won't show. All I care about seeing is the speed, actually. That's fine. We'll save that. We'll drop our initial speed change down to 5. And our speed up interval should be set to one initial speed up interval here. And then we're saying max speed is 100 for the moment. Let's give that a go. Right, you around here, you have a bit of a jump. And that needs to ramp up when it does it, rather than just a sudden add. That's a little bit better. I mean, for the amount of objects you've got there, it might have to be a little bit different from this, but I mean, there's going to be a lot of tweaking before it's anything near a game, but cool. Right, so we've seen our global gravity. That seems like a nicer value. Don't need that, don't need that. We can go back to here, and we were having a look at, with the obstacle, trying to kill the player if you flow with the obstacle.
By default, I'll set its value to true. At the top of the
So in our player movement,
function, I'll add a line saying if not alive, the exclamation mark means not, then return.
overall alive. That's
This
true.
simply means if the variable alive is not true, stop running the function. If you remember,
Now, I don't want to do that though. Fixed update here. So we want to say if not alive, then we're gonna reset. No. What do we call it? Call it restart. Come on, this. Right. But we don't have our context here, so how do we trigger that? I wonder if we can trigger this. So let's put this in our braces. Not quite. Okay, so trigger. Oh. User input. Unity. Trigger an input action. There we go. Not what we want. By the looks of it. How do I enable input actions? That's not what I want to do. Okay, trigger input Unity. Inputs. So the thing is, I want to call restart, but I don't have the context, do I? Why do we need the context? Okay, let's see. Unity input action without parameter. Let's have a look at this. So input action. Okay. It's on the new inputs, right? Yeah. Map. Part of an action map or global on action change callback, globally listen for action activity. Okay. See, a lot of this is just more built around how C# works, I think, rather than how Unity works. I mean, they're both intertwined, but probably something I can separate out. We're at the end of that playlist. Let's have a look for something new. What should we go for? gotta make sure I'm on the Stream Beat playlist. Okay, public playlist. Okay, what's the ambient like? Maybe the lo-fi. Yeah, let's go with that. Okay, so we want to trigger it. I want to trigger the input action, but without having to subscribe to it, because then we won't have the callback context, right? Ah, we might be able to do that, right? We do a context, and then we do a lambda expression that calls restart. Yeah, there we go. Right, now restart doesn't need to take in the context because it doesn't use it at all. And then we can just call the restart function here. So this is essentially just throwing away that context because we don't need to, we just need to know that the restart action is performed. But then we can call it again when we want to. So, right, going back to...
This function is where we move the player. New function. To do this, we need to be using Unity's Scene Manager. So scroll right to the top and add using Unity engine.scene management.
See, I didn't like this version. I tried doing this
back to the die function
on our stream yesterday.
Scene manager dot load scene.
And
we'll give it the scene manager dot get active scene.
Yeah, when we tried to do this, it was just using up too much memory. It's reloading the whole scene.
This means that the scene manager will load the scene that we are currently in, or in other words, the game will restart. Now if we go back to the obstacle script, in the onCollision enter, we first need to check that the object that collided was the player. So to do that, we'll say if collision to get the input dot game object dot name is equal to player in quotes.
Okay, so we go here. I think we can do this without the bits that he's including. So collision dot game object dot name equals player and double equals. Oh, because otherwise you're setting it. Okay, player. Then I reckon we can go player movement. Oh. Player movement, which we want the objects that we've got above. Dot alive. Is it public? Did I make it public? No, I made it private. That's why. Public ball alive true. Right, dot alive equals false. Right, so that should then kill off our player. So that'll trigger the restart. And then our last bit here. We want to set it to alive straight away so that we don't have to worry. So we'll do live equals true. Right, I think that should reset us. We'll see how it goes. So now, I think when we're moving left and right, we can restart ourselves with escape. And if we collide with an object, nope. Why is that not setting alive to false? Not alive. Obstacle, collision, player. Let's just double check that we're getting hit here. Kill player. And let's see if we're going to this restart. And here we're doing our restart. And then we've got our console up here. We'll have a little look. Okay, so when we restart, that's fine. But we're not getting to that kill player. Because we've probably not hooked something up properly. Okay, pause. So in our obstacle, do we need to put the player object in our obstacle? It's not there, but if we go into our prefabs, in our obstacle, do we have an obstacle script? No. It's in the grounds tile, isn't it? Script, obstacle. No, again, that's not it. Let's see what he says.
This checks that the object that collided with the obstacle is called player, and if it is, we can call player movement.die, which is the function that we just made. I'll quickly move the comment up here so that makes more sense. Another time that we would want to restart the game is if the player falls off the edge of a platform. To do this, we can go back to player
We're not got that in our in what we want to do with our game. Okay, let's do our .die then. So public void die alive equals false. Right, let's save that. And then in here, let's see player movement.die. Something is not set up right here. Right, so in our player movement, we have a public ball alive. Actually, we don't need to have that public anymore. Let's just do that private. So alive is true. Then, if we're not alive, we go straight into restart rather than this. Let's do an else here. And we'll put all of this in our else clause. We're only doing this if we are alive. That's fine, that's fine. Restart, fine. We set alive to true. And if we die, we set alive to false. Right, let's check here. What we'll do is in our jump command, we'll just do our die function. And so that if when we jump, we die. Right, let's first see if we can collide with something. Nope. But if we try jumping, there's our restart. Okay, so that's all working. It's just the collision that's not working.
Function underneath the horizontal input. We'll add if. I'm pressing tab twice to insert this snippet. So if transform dot position to get the position of this player dot y. Y is the vertical position, remember? And then we'll say is less than -5. We will kill the player and search for obstacle. With that done, let's exit out of the obstacle. Go to our prefabs folder, and in our obstacle, make sure that you add the obstacle script to it. You can simply go add component and search for obstacle.
That's why. Right, so in our prefab here, we need to add obstacle script. Right. Hopefully that's it. So now we run into it. Yeah. Cool. Right, that I think is a good pause point. I'm going to do a little break from screens. So probably 10-15 minutes, something like that. Let's just set up our timer. So good time to go get some water, take a little toilet break, or have a little wander outside. What's 15 minutes? 600. No, that's 10, isn't it? 900. 900 seconds, I think. Let's have a little look, see if that's the case. And we'll do a little be right back message. There we go. Okay. Take a little break. We'll see you in 15 minutes. Alright, and we're back. So, what we just got to is the first set of obstacles that we encounter here. Reset the player, reset the game. Ooh, I wonder... That looks like it's still okay. Let's just check that these tiles are resetting as expected. Oh. Yeah, I need to do a speed run from that. Oh yeah, and we've also got kill player on jump. Let's get rid of that one. Let's see. How do I ramp up the speed? I suppose we don't want just a straight addition here. So I think what we want in here is we want a for loop. No, for's gonna execute all in one loop, isn't it? So if speed change, do we have an initial speed change? Yeah. If speed change greater than 0, we want to do speed plus plus. Speed change minus minus. And then else, we do our reset here. And if we save that, it should format. Okay, so when we get to our speed up interval, we loop through the number of times we have, sorry, for the amount that we want to change our speed, each frame will speed up by one. Yeah, plus plus is just plus 1, isn't it? We might want to do we might want to do a smaller speed up, actually. So per frame it's not a plus 1 value, it's like a plus 0.5 or something like that. So we don't want to do this anymore. Yeah, let's make this instead, because speed at the moment we've got as a float, right? Yeah. So we want to speed it up gradually. So we do a quarter at a time. And then speed change minus equals. Speed change is float as well, right? Float. Float. Yeah. So we do this. Then as it comes down to 0, we reset it. Fine. And speed change equals initial speed change. Okay, so now that should be more ramped up speed change when we get to that point. I suppose for the moment, while we're not using it, we can hide the tutorial window. And we'll bring that back if we go back to that. Right, so... Oh. Okay, we need to make it so that the first task can't spawn obstacles. You don't have time to react there. But if we look at the player... okay, that felt like a bit more of a natural speed change. So our speed is 5 at the moment. We'll keep an eye on our speed. There we go. It ramped up to 15. And then we're going to get another ramp up here. Oh, no. See if we can last in our game until we get the next ramp up. I think that was the start of it. So actually, instead of that, let's do, let's pause this. Let's do an initial speed change of 5 rather than 10. But we'll do it more frequently, and we'll do, actually, we'll just do 2 instead of 10. But we'll do it a bit more frequently. Okay. We're going to start at 5. We should go to 7 pretty soon. Yeah. And then 9. Yeah. 11. That feels a bit better. So I think we've got too many obstacles here that can just kill you. So we'll drop that spawn rate a lot lower. Because especially at later, at higher speeds, it's going to be impossible to stay away from them. Oh, it's even if it's just on the edge. No, that doesn't hurt. That doesn't hurt. Okay, so you got 3... Oh no, the middle one overlaps a bit too far. Right, I think I want to make the obstacle just a little bit shorter. So if we go into our project, obstacle, we want the... Well, the scale's just 3. Let's see what that does. Yeah, there we go. That's a bit better. Just for the moment, so we can pass either side of them a lot easier, and there's a little gap between them, so they're not just one mass. Actually, we could randomize the width of the object as well. We can still jump over individual obstacles. That's not too bad. See, can we get... How far can we get? Oh. Right. It's starting to become a game. there's actually some interactions and mechanics now. Right. Now, I don't know if we want to continue. Let's
With that done,
let's continue on
exit
for a little
the
bit.
obstacle prefab and hit play to test the game.
We need to bring this window back in. There you go. Right.
You'll see that anytime I hit an obstacle, the game simply restarts. Now if I fall off the edge, the game also restarts. Something that I believe would be nice to have would be a delay between hitting the obstacle and restarting the game. To do that, we'll go back to the player movement script. Under the die function, I'll create a new function which will be void restart. This will be responsible for restarting the game. I'll cut and paste our scene manager.load scene line into this function, and that's all that we'll be adding to it. Now in the die function, I'll call the restart with a delay by saying invoke, and then in quotation marks, restart, make sure you spell this correctly, and then as a second argument, so with a comma, I'll add 2. This will call the restart function after 2 seconds.
Oh.
Back in the editor.
That's way better than all the other bit that I was looking at. Oh, actually, did we have it in our ground tile when we destroy game object after a certain amount of time? Yeah. Okay. Okay, so in die, yeah, we don't need it here actually. So if we get rid of all of that, bring this back in, get rid of you, and save. Okay, so when we die here, this is where we want to invoke restart after 2 seconds then. We'll stick with what he's done here. And then what we want to do is at the start, I think what we want is a new public. No, we don't want public. We can do it as public for the moment. Public void. Oh no, not that one. Initialize. And this is going to be these things. So get rid of all of that. So when we die, we wait 2 seconds, and then we call restart. We become alive, our speed is 0, speed changes back to 1. We reset all the ground tiles, we move ourselves back to the start, and then I want to invoke initialize after 2 seconds. Why is this not liking my spelling? What does it think? Initialize spelling suggestions. Because it's not. It's American spelling. Let's add in the British spelling. Right, we'll save that. And now give it a check. So at the start of the game, we should be still for like 2 seconds. And also, is assigned but values never used. point actually. What do we need a life for? Let's get rid of a life altogether. Oh, because it will still be updating to move us. Yeah, okay. So what I want to do is put them back in and actually if alive is all we need here. That goes forward and we get one of these and we save. Right, let's jump back in. We should lose all of those console errors, that's fine. Clear this console. And we'll start. So we'll start. We have 2 seconds and then we should start, yeah. Cool. So it's starting to speed up. So now, if we hit one of the obstacles, what should happen is we stop for a couple of seconds and then we get put back to the start, and then it's a couple of seconds and then we'll start moving. Right, so stop for a couple of seconds, back to the start, and continue. That looks okay. It's time for, basically it's time for animations. Right, I wonder if I can make it so that objects don't spawn, the obstacles don't spawn at the start. So on our ground tile, ground spawner dot start. Start does this. Oh yeah. So all I need to do is I'll duplicate this. And then for these start tiles, or starting ground tiles, that's probably a bit better description. And in our starting ground tile, we don't want our obstacle spawners. Right, so we save those. And then in our ground tile command, we want another ground tile here, and this is our starting ground tile. We want here our game object of ground tile. And when we call this, we call starting ground tile. So let's save that. And then here, when we do this one, this wants to be a standard ground tile. So ground tile, ground tile, ground tile. This is this, Game object ground tile. That's what I'm looking for. Yeah, okay. And then when we hook it up in here, which will be on our, not here, on our ground spawner object. Yeah, here we go. Then we got our starting ground tile here. So hopefully the first 15 tiles should have no obstacles. I think that's a few too many. So, argument exception. The object you want to instantiate is null. Transform child out of bounds. Where's this? Spawn obstacle. Ah. So we only want to do that. Ground spawner, spawn tile. So let's say the first 5. And then we'll do this again. 0 to 10. For a normal ground tile. So we're creating a ground tile object. Let's save that. So then in here, we only want to do this if it's a normal ground tile. Ground spawner, spawn tile. I think it might be easier to have a separate script for the starting ones. I might do that actually. I think that's going to be easier. For the moment, I don't want to go through and debug all this kind of stuff on screen. Probably going to be take a little while to get my head around it. So let's just call this a starting ground tile. And we'll go to our prefabs starting ground tile. And this one doesn't have the ground tile script, remove component. We want this to be our starting ground tile script. We need to open up. Starting ground tile. So we don't want to spawn random objects. This one, get rid of all that. So all it does is spawn a new tile. And this will only spawn the normal ground tile. Right, so our starting ground tile script is this one. We clear that. Let's have a little look, see what happens. I feel like there's a little bit more to do, but the object you want to instantiate is null. It's not too bad. Right, let's see where this is. Let's pause this for a moment. We ground spawner. Oh, it is opening. Line here, spawn ground tile. What's causing me to slow down so much? Where do we set which object this is, though? Should that be in the script for the starting ground tile? So we look at the ground tile object. We do. Oh no, we had the obstacle there. How about our ground spawner? Yeah, it's got those two separate. I think what we want to do is this. Because it's only used there. And we want to tell it which object to use. Destroy game object. So now we go to our prefab starting ground object. So our ground tile is this one. And then we'll go back to our game. Let's zoom out just to make sure which one's being deleted. Still getting that issue. So we have a look at this. The object you want to instantiate is null. Instantiate rotation at that. This one. Let's make this public so that we can assign the object directly. So on our we're in run mode. Give it a second. We go back to here. Click on our grounds. No, we want to click on our prefab ground tile, and we want to assign ground tile as the game object. So yeah, we have a few starting ground tiles with no obstacles on them. And then here it should be clone, clone. Oh, if we set up a feedback loop there. When these get to clone, clone, do they go clone, clone, clone? Yeah, okay, we don't want this to happen. So pause that. Get rid of these. Let's just tidy up some of this for a second. Let's check that as well. So I'm wondering if, because we're only destroying objects of type ground tile, if the start tiles get duplicated. So let's see if when we start, if we reset a couple of times, do we get loads? Yeah, there we get loads of those starting tiles. Object of types. Nope. Can I do ground tiles plus equals of starting ground tile? Can we push onto this array? So how do we Unity add members to array? C#. Oh, close enough. Okay, well in that case, let's do a destroy tiles function. So private void destroy tiles and function, and we want our ground tiles array, which is up here somewhere, isn't it? Ground tiles. That's the one we want. Oh no, that's not going to work, is it? Can I do game objects? We'll do that. take 0. Let's just see if we do destroy tiles. Oh my god. Copy and paste. And then do this. We do game object. We do like an any. Oh, it's bad practice, but just having a look. Oh my god. Oh, auto completing. No. Okay. So this needs to be a type game of ground tile. And then that destroy works. But then we can't do, pretty sure it won't let us do starting ground tile here, will it? So really, I think this is where we start looking at extending classes and all that kind of stuff, but I don't know enough about object-oriented setups in C# for that just yet. So the simple way to do this is just do another function. And we'll call this starting ground tiles. And really, I might as well have just done it in place here. But let's have a look. Okay, so that should get rid of our starting tiles as well now. We might still have that issue. Sort of saying it was trying to instantiate something that's null. Right, yeah, so when we restart, it's killing them all, that's fine. Oh, we're still going to get clone of planes, aren't we? Yeah. But we're not getting our other error that we were getting before. Trying to instantiate a null. What's the chance of that happening? Wait, it shouldn't be able to spawn 3. Because it's cloning, right. Because it's clone. It's gonna have, I think it's gonna have the initial barriers that were put on the first time the block was. And then it's also randomizing adding another block. So yeah, we're getting 3 is going to be much more. Okay, there's definitely an issue there. Right, so how do we stop it being clone of clone? where are we using ground tile here? Just that bit. So what if we don't have this in here? And we just do a ball starting tile, right? And then we say if starting tile, and we need to wrap that in brackets. Then we do this with a starting tile. Else we do this. And actually we don't need that repeated all the time, right? So we do game object temp, and then we don't have to define it here. And then this is going to be true, this is going to be false. We said that, and back in here we do false. So now ground spawner is using the game objects that it's fed into. It's not the ground tile spawning ground tiles. It's everything that's coming from the spawner instead, which I think is better. Let's see if that works. Don't know why we got starting ground tile spawned. Okay, so it's a bit better, but I don't know why it's doing that though. Spawn tile false. False will be our normal ground tile, not our starting ground tile. Oh, because we haven't updated here. This is always going to be false. And we don't need that anymore. Cool. I think this will be working. That's looking better. And we shouldn't get clone. Good. Right, so we're not going to get our triple barrier setups that we were getting before. I think that jump could be a little bit tighter. Maybe a bit more power to start with, but a little higher gravity. Cool. Right. Good start. Let's go on to what's the next part of this tutorial?
I think it would be nice to give our obstacles a different color. So I'll go to the materials folder, right click, create, material, and I'll call this obstacle_matte, short for material. I'll set its albedo, which is its color, to red. Finally, I'll open up the obstacle prefab, go to our materials folder,
I think we'll just
and
bring
drag and
in,
drop our obstacle material.
we'll bring in an asset instead.
To make testing a little bit nicer, I'll hover over the game view, then hit shift space to maximize it. Now I'll hit play. and you can see that we have a nice ground. We have obstacles which are red, and restart the game after 2 seconds when the player touches them.
So
If the player falls off the edge, the game will also restart after 2 seconds.
I think we had a look in here for our...
One big problem is that the obstacles spawn right from the first tile, so the player doesn't have enough time to prepare, and sometimes an obstacle will be unavoidable. We'll be fixing that in the touching up video, coming in 2 weeks, so stay tuned for that.
Oh. He was going to take us through the steps to do it. But it's fine. It's, I think it's better to learn just by trying. Trying and failing is good. If we see like his version is a lot better, then we'll update with that. Right, let's have a look for something to put on our obstacle. Maybe like a wall or something like that. Don't want these. We want materials. Bark, book, canvas, charcoal, clay. Could do the cobblestone wall. Let's try that. Dark wood, fabric, gold, granite, iron. Maybe one of these two. I think those are what we'll go for the moment. Oh, here's some more, aren't there? Textures. Not really looking for bark. Books, canvas, charcoal, wool, maybe. I think we'll go with the ones we've got. Yeah, okay, let's import the ones we've just said. And what we'll do is we'll shift those 3 into our materials folder. That didn't work, did it? Oh, we put it up here, that's why. Into materials, can we do that? Why can it not go in there? Get rid of that, let's get rid of that. That can't go in there for some reason. There's already one in there. Yes, there is. So we can just delete that. I have a feeling that this isn't loaded though. So in our prefab, we open up our obstacle and material. Try and put a stone wall on it. No. Okay. Maybe a .mat file isn't what we want. I think if we take those off, and if we go down to our textures instead. So what was it we're looking for? Cobblestone, stone, stone. Yeah, okay, we might have to be these ones. So I think we did that one, and number 3, and cobblestone will fix D. Yep. Let's import those three instead. That's better. So it's really textures that I want, not assets. So I can delete this. Oh, it needs the texture for the material, right. So we get rid of these. Then I can't find the texture, but we can just put the material on instead. That's okay. This will do for the moment. So now if we select our obstacle and somewhere in here, we set our tiling correctly. So 3 by 1, wasn't it? On this instead. Oh, shame, resets. What does this one look like? I think I like this one best. Yeah, it doesn't really look right on here, but these are just dummy textures for the moment. Cool. Right. Let's have a look at the next one.
That's all we'll be covering in this tutorial. Next week, we'll look at spawning coins for the player to collect in-game points. Thanks for watching, and I'll see you in the next one.
Coins.
Hi guys, and welcome to the 4th video in the series on making a 3 and this runner in Unity. In this video, we'll be adding coins, spawning a random number in at random positions on each tile, adding to the player's score whenever they collect one, and displaying the score on the screen for the player to see. Before we get started, don't forget to hit like and subscribe and ring the bell so you don't miss another video. Without further ado, let's get started. The first thing I'm going to do is right-click in the hierarchy and create a new cylinder, so 3D object, cylinder, and I'll click F2 to rename it and call it coin. I'll set its scale on the X and Z to 0.7, and on the Y to 0.05 to make its shape more like a coin, then its rotation on the X to -90 to make it stand up. Next, I'll create a new material, so in the materials folder, right-click, create, material, and I'll call it coin underscore map short for material. I'll set its color to yellow, and then apply it to the coin by dragging and dropping it on. Finally, I'll select the coin and find its collider, so that will be a capsule collider. In the collider, I'll check the is trigger box. This means that the player will still be able to interact with the coin, but won't actually glide and have its direction change when it touches one. Next, let's create a new script. So in the scripts folder, I'll right-click, create, C# script, and I'll call this coin. Give it a moment to compile.
Just a little bit too quick. Do we have a coin in that? We don't want materials. Can we get rid of those? Or is that completely messed up our prefab? Yes, it has. Oh, okay, right. Can I read that up one? Yeah, okay, cool. Right, so our coin, we want to have another asset. Let's see if we've got a decent one to use here. I wonder if you can search within the pack. That would be useful. Nope, doesn't look like it. Right, not this, not this. There is gold, isn't there? It's not in here. Okay, so we'll just do a create new material here. So coin underscore map. And then we're going to set this to a goldy color. And we're up around there. That's all right. And our coin is going to have that on it. I'll do.
Set its color to yellow. And then apply it to the coin by dragging and dropping it on. Finally, I'll select the coin and find its collider. So that will be a capsule collider. In the collider, I'll check that it's trigger box. This means that the player will still be able to interact with the coin, but won't actually collide and have its direction change when it touches one. Next, let's create a new script. So in the scripts folder, I'll right click, create C# script, and I'll call this coin. Give it a moment to compile, and then double click to open it up in Visual Studios. In here, we simply want to detect when the player runs into the coin. So let's create a new function. So void on trigger enter.
Right, let's see if we can. Oh, he's already started on it. On trigger enter collider. Let's get rid of that.
This is the default function called when an object interacts with a trigger. And remember that we set this coin's collider to be a trigger.
And we just want to.
We need to first check that the object we collided with is the player, and then we need to add to the player's score. And finally, we need to destroy this coin. To check that the other object was the player, let's type if and then other to access the other game object. You can see it's input over here.
Oh, it's called other, isn't it?
Yeah. Dot name is not equal to and then player. Now you'll notice that we're checking whether the item is not the player, not that the item is the player. And what we're going to do is type return in here. This means if the object is not the player, we'll stop executing the rest of the function. To destroy the game object, we simply have to type destroy and then game object with a lowercase g to signify that it's this game object that we're talking about. Destroy destroys object and game object is a reference to this game object. Something I believe would be quite a nice visual effect would be to have the coin rotate. To do this, let's add a new public variable at the top. So public will be type of float, and I'll say turn speed. By default, I'll set this value to 90, meaning that it will rotate 90 degrees every second. In the update function, remember this is called every frame, I'll say transform.rotate 0, 0, turn speed times time.delta time.
I think if it's colliding already with either the player or with the with a barrier, then we'd want it to be destroyed anyway. You don't want it to spawn in on top of a barrier and then you can't collect the coin. So I think what we're going to do is just do our destroy. No. On trigger enter. Yeah, I think we can just destroy it straight away. Game object. And then in our update, we're saying transform.rotate capital R, isn't it? Rotate, open bracket, 0, 0, turn speed, dot, no, times by time dot delta time.
This will rotate the coin along its z-axis by 90 degrees every second. Time.delta time is the amount of time passed between the last frame and this frame, and as update is called every frame, this ensures that the coin will always rotate 90 degrees every second, regardless of the frame rate. With that done, we can now return back to the editor. The first thing I'll do is select our coin object, and drag and drop the coin script we just made onto it. Next, I'll set its transform position to 0, 0, and 0, and then go to our prefab folder, and drag and drop it in to turn it into a prefab.
Okay, let's add that prefab. So we've saved that, we're going to go here. We're going to drag our script onto the coin. We're going to set it back to 0, 0, 0. And then we're going to put it into our prefabs. And then we're going to delete it. Oh, we've done this again. It was this one, wasn't it? I think that's what we need to do. No. Not what we need to do. I think it's because we're missing the other parts of the material that were in the pack. I wonder, do they spawn in as pink or do they have the texture? They have the texture and that's good enough. Okay. So we have our coin.
Delete the coin from the scene. Now we need to spawn the coins. To do this, we're going to go to our ground tile script and scroll to the bottom, and we'll need a new public variable type of.
So we're in our normal ground tile script. And game object.
And I'll call this the coin prefab. Next, I'll create a function, so this will be void spawn coins. It will not take any input. And inside it, we need an integer for how many coins we want to spawn. I'll call this coins to spawn. For now, I'll just set it equal to 10. Next, I'll type 4, then hit tab twice to insert the snippet. And the only thing I'll change in here is from length to coins to spawn. This will run any code in here 10 times.
Right, void spawn coins. Oh, coins. As a function. And we're doing int coins to spawn was 10. 4. Int up to coins to spawn.
In here, we first want to spawn a coin, then set its position to a random position on the tile. Spawning the coin is simple. We just have to say instantiate, and then coin prefab. You'll remember that instantiate is Unity's fancy way of saying spawn. Now we need to get a reference to the coin that we just spawned, so that we can change its position later. To do this, in front of the instantiate, I'll add game object temp, short for temporary, is equal to the instantiated object. This saves the object we spawn in a variable called temp. To get the random position, I'll create a new function. This is going to be a little more complicated, so just follow along with me, and I'll explain it all at the end. This function will return a 3D position, which is called a vector 3 in Unity. So type vector 3, and then I'll call this function get random point in collider. This will take an input type of collider, and I'll call this collider with a lowercase c. And finally, open and close some curly braces. To get this position, we're going to use what's called the collider bounds. This is essentially how far the collider reaches. The collider's minimum bounds is how far left it goes, where my mouse is over here, and its maximum bound on the x is how far right it goes. Minimum z is how far back it goes, and maximum z is how far forward it goes. Similarly, minimum y is how far down it goes, and maximum y is how far up it goes. Essentially what we're going to do is create a new vector 3, which will ask for an x, y, and z value. These values are going to be a random number between the minimum and maximum values of each axis of the collider, which will ensure we get a point on the ground tile. In code, we would write this as vector 3 point to declare a new variable type of vector 3, which remember is just a position, and I'll set this equal to new vector 3, and if I open some parentheses, you'll see that it asks for an x, y, and z value. To make it easier to read, I'll separate these onto their own lines. So for the x value, we're going to say random.range to get a random number within a range, and this will be collider.bounds.min.
3 point. Plus new vector 3.
Remember, this is how far right it goes. I'll put a comma to say that we are now inputting the y position. Then I'll copy and paste the line that we just used for x, but replace x with y.
Random.range.
Finally, I'll do the same thing for z.
Random.
At the end, I have to remove this comma, as we are not inputting any more values after this. At the end of declaring this vector 3 point variable, we're going to need to put a semicolon to indicate that this is the end of the line.
Collider.
We could have easily written it like
Bounds.
all in one line, but I decided that would be easier to read.
Min.
And separated them out.
Dot x.
The last confusing thing that we're going to have to do is say if the point is not in collider, dot closest point, and then point.
X dot
Inside this if statement,
X.
I'll say point is equal to get random point in collider.
dot
You don't
bounds.
really need to worry about what this does. As it
Let's
does
just pause that for a second while I copy these. 1, 2, 3. We want commas, not semicolons. No comma at the end there. Okay, and a semicolon here. And then these need to be y and z. Y and z. And z and y. I'll do it like that, yeah. Okay, and then we're saying point is not equal to collider dot closest point, then point equals, oh, so it's a recursive function. Okay. So if our point is not equal to collider, what's the closest point? I don't know what that is. This is the point collider that has the closest. Okay.
When it simply checks whether the random point that we generated is on the collider. And if it isn't, it will generate a new value for the point that is on the collider. This should never fail, because we are only taking values from within the collider in the first place, as you saw up here. But it's a good precaution, in case there's some confusing error. If this whole function makes no sense to you, don't worry, as I promised you'll understand it after using Unity for just a bit longer. Just ignore it, and let's continue
fine.
the rest of the code. After the if statement, let's say point.y is equal to 1. Remember, y is the up axis. This will ensure that the coins all spawn at the same height. And finally, I'll return point. We can't simply say return in this case, as we had declared up the top that this function should return a vector 3 or a position. Let's take a look at that function now, and back in the spawn coins function, we'll say temp.transform to get the transform component. Remember, this holds a position, rotation, and scale.
I'm going to do that instead. Because we've got a jump function in, I think if we set the range from y equals 1 up to a max y of our collider bounds, then it can go up to the max of the tile, which I think goes up to y equals 5, so we might not be able to collect all of them. Because I don't know how high we can jump. Let's maybe just set that between 1 and 4 inclusive. Inclusive of 1, exclusive of 4.
Position, and then we'll set this equal to get random point in collider. And for the collider, we'll say get component
Dot
in angular
transform.
brackets and finish off with parentheses.
Dot position
What we are doing here
equals
is setting the position of the coin that we just spawned equal to a random point in the ground tile collider. If I go back to the editor, I'm in the ground tile here.
get components.
The green outline is the collider, and you can see that this only extends as far as the ground does. This means that the coins will always respawn within the ground where the player can reach. I'm in the ground tile here. If I select the ground to get its position, and then we'll set this equal to get on equal to a random point in the ground.
Collider. And we execute that. Not all code paths return a value. Oh, do we need to return? I missed that, didn't I? Yeah, we need to return point.
That this function should return a vector 3 or a position. Let's take a look at that function now, and back in the spawn coins function.
Cool, save that.
We'll say temp.transform to get the transform component. Remember, this holds position, rotation, and scale. So we'll say dot position to get its position, and then we'll set this equal to get random point in collider. And for the collider, we'll say get component in angular brackets collider and finish off with parentheses. What we are doing here is setting the position of the coin that we just spawned equal to a random point in the ground tile collider. If I go back to the editor, I'm in the ground tile here. If I select the ground tile, the green outline is the collider, and you can see that this only extends as far as the ground does. This means that the coins will always respawn within the ground where the player can reach them, and never just out in empty space, for example somewhere over here. Back in the script, in the start function of the ground tile, I'll call the function that we just made, so spawn coins. Now we should be able to test it, so if we say...
And where we're spawning obstacles. Here, we want to spawn coins.
Script and go back to the editor. In the inspector, make sure you assign the coin to the coin prefab variable, and now we should be able to hit play.
So in our ground tile, we now need our coin prefab, and then we can go back and wow, loads of coins. A bit too many coins, I think. So they disappear when we run into them. I think the top ones are a little bit too high. No, can we collect all of these? We can collect all of these. Okay, nothing's out of range. That's good. Cool. Right, let's bring that way down though. Coins to spawn is like 3 per tile. I think is probably a bit more sensible. Or you can just collect them just before. Oh, and there we go. Okay.
The coins are spawning now, that's great, and we can also collect them, but nothing happens when we collect them. Additionally, if I pause the game by hitting Shift Control T, and then go back to the scene view, you'll see that all of the coins behind the player aren't being destroyed.
Oh yeah, of course.
This isn't an issue, but if someone managed to play this game for a long time, we might end up with billions of objects in the scene, which might create lag in the gameplay. This is a simple fix, so let's go back to the ground tile script, and this is a simple fix.
Yeah, so this is just going to be when we destroy our game object. We also want to destroy the coins, right?
So let's go back to the ground tile script, and in the spawn coins function, I'll simply add transform as a second argument to the instantiate. You can see that transform refers to the parent, meaning that the coins will be parented to the ground tile, and therefore when the ground tile is destroyed, the coins will also be destroyed along with it. To prove this, let's go
Oh,
back to the
really?
and hit play.
Oh, that's way easier. So where's this? Where we are instantiating it here. We just put in transform. That's so much easier. So let's zoom out a bit here. Oh no, I want to zoom in a lot more. Yep, cool. Cool, and then we're going to put in some kind of score. Right, I'll stop playing that.
You can see that transform refers to the parent, meaning that the coins will be parented to the ground tile, and therefore when the ground tile is destroyed, the coins will also be destroyed along with it. To prove this, let's go back to the editor and hit play. You can see in the scene view over here that there are no coins being left behind.
Yep.
In the onTrigger enter function, at the very top, I'm going to add if the other.gameObject.getComponent obstacle is not equal to null, and inside that, I'll say destroy game object, and then return. What this does is check if the other game object is an obstacle, because only obstacles will contain the component obstacle, which refers to the script that we made for the obstacle, if you remember. And if it is an obstacle, it will destroy itself and stop executing the script. But if we go back to the editor and test it, you'll see that this is not working. This coin in the bottom right of the screen here is currently intersecting an obstacle. If you cast your mind back to the first tutorial we did, you'll remember that for collisions to work, at least one of the objects requires a rigid body component. So to fix this, I'll simply double click on the coin prefab to open it up, and scroll to the bottom and add a rigid body component. In here, I'll check is kinematic, which simply means to ignore regular physics such as gravity.
Right, okay. So on our coin, we're going to add our rigid body, and we want to say is kinematic. Okay. And then back here, where we said what we would do is just destroy anyway. We're not going to do that anymore. We're checking if we're intersecting with other. Right.
Now we should be able to test it out and see that it's all working. You can see that there's no coin spawning inside obstacles anywhere. That's great. the last thing we're going to do today is keep track of the player's score. To do this, let's go to the scripts folder, right-click, and create a new C# script, and I'll call this the game manager.
I want to see coins again.
Remember that for collisions to work, a rigid body component.
Where's our coins?
And then return. What this does.
Okay, so if other dot game object dot get component obstacle and if it's not equal to null, then we want to destroy the coin. And return. Okay. And at the moment we're returning from here. Cool.
Is check if the other game object is an obstacle, because only obstacles will contain the level. What this means is that we did not set it to be public in a topic, so don't consider where. That's great. The last thing we're going to do today is keep track of the player's score. To do this, let's go to the scripts folder, right-click, and create a new C# script, and I'll call this the game manager. Give it a moment to compile, and then double-click to open it up in Visual Studio. In here, we're going to need a variable, type of int, and called score. We're also going to need a public static variable, type of game manager, called inst. Create a new function called awake. This function is called at the very start of the game, even before the start function, and inside it, I'll type inst is equal to this. This is definitely not a beginner topic, so don't concern yourself with what this does, but it's the quickest way to achieve what we want, which is why I decided to go with it. If you want to research it, this is called a singleton, but I won't explain it in this video. A variable, type of int, and called score. We're also going to need
Right, in our game manager script, we want an int score. Let's get that back to there. Okay.
public static variable, type of game manager, called inst. Create a new function called awake. This function is called at the very start of the game, even before the start function, and inside it, I'll type inst is equal to this. This is definitely not a beginner topic, so don't concern yourself with what this does, but it's the quickest way to achieve what we want, which is why I decided to go with it. If you want to research it, this is called a singleton, but I won't explain it in this video, as I want to keep it simple. If you can't be bothered researching it, but want to know more, drop a comment below, and I'll try to explain it as simply as I can. Let's go to the coin
Awake.
script, and now to add to the player's score, we can simply say game manager dot inst dot score plus plus.
Inst
However, you'll
equals
see that we're getting
this.
an error here, and it says that the score variable is inaccessible due to its. What this allows us to do is go to the coin script.
Inst equals this. And awake. Yep, that's fine.
If you can't be bothered researching it, but want to know more, drop a comment below, and I'll try to explain it as simply as I can. What this allows us to do is go to the coin script, and now to add to the player's score, we can simply say game manager dot inst dot score plus plus. However, you'll see that with
So in here, we'll do game manager dot inst dot score and oh, no score, and we're going to do it instead as each coin is worth 100.
we are getting an error here, and it says that the score variable is inaccessible due to its protection level. What this means is that we did not set it to be public, so the coin script is not allowed to access it. To fix this, I'll simply add public in front of the score variable. Now every time the player collects a coin, the score should increase. Plus plus is a quick way of saying add 1 to the variable score. Now in the editor, I'm going to exit out of the coin prefab and create a new empty game object, which I'll call game manager. I'll add the game manager script to it, and you can see the score variable here, so as we collect coins, you should see that increase. I'll also right click and go UI text.
I'll give it a second. The new empty game manager. Manager. There we go. We drag the script onto this. No, we drag the script onto this. There we go. And we add UI text.
Call this the score text. In the inspector,
Oh, it's not on the game manager. This is just out here. And this is score text.
I'll say it's text to say score, colon, 0.
Over here, score 0.
I'll also set its font size to 25. Next, I'll click on the icon in the top left-hand corner and select the top left one. This means that its position will be relative to the top left of the screen. If I select the 2D view in the scene and scroll out, you can see that this cross icon is in the top left. This represents the anchor of the object. So if I changed it to top right, you can see that it moves wherever I put it. I'm going to leave that in the top left, and then I'll set its position on the X to 90, on the Y to negative 25. You can see that it looks much better in our
Position X 90, Y minus 25. Right, okay. You change the font or something?
I'll add the game manager script to it, and you can see the score variable here. So as we collect coins, you should see that increase. I'll also right click and go UI text. I'll call this the score text. In the inspector, I'll set its text to say score, colon, 0. I'll also set its font size to 25.
Right,
Next, I'll
okay.
click on the icon in the top left-hand corner and select the top left one. This means that its position will be relative to the top left of the screen. If I select the 2D view in the scene and scroll out, you can see that this cross icon is in the top left. This represents the anchor of the object. So if I changed it to top right, you can see that it moves wherever I put it. I'm going to leave that in the top left, and then I'll set its position on the X to 90, on the Y to negative 25. You can see that it looks much better in our game view now. Next, I'll click on the main camera and change the background from a skybox to a solid color. I'll click on the background. And choose a light blue color, but remember, you can use any color you want. This looks much better. Finally, back in the game manager script, we need to change the text on the screen to changes. To do this, we're going to need to add a new using tag at the top. So under using Unity Engine, I'll add using Unity Engine.ui. This allows us to access and edit text elements. With this done, we can
For like a blue somewhere around here. That'll do. Oh, and then with our score text, can we change the color? Where do we set the color of the text? Color here. Something over like this. Okay, and then in our coins, no, game manager. Using Unity Engine .ui.
now add a new public variable, titled text, and I'll call it score text. Let's also add a new public function, so I'll say public void increment score, open and close parentheses, and then a pair of curly braces. In here, we'll say score plus plus, remember this simply adds 1 to the score, and then score text.
Boy, okay. Increment.
Dot text to access the text component of this object is equal to score, colon, this is in quotation marks, and then out of the quotation marks I'll say plus score. This sets the text of the text element to score followed by our current score. The very last thing we need to do in code is go to the coin script and change the game manager.int.score++ to game manager.inst.increment score.
Okay, so what we want is an int here. Add score. Oh no, score change. And we're going to call this change score. And we don't want that there. And then what we want is score equals score. No, plus equals score change. And then save that, and we're going to coins. And rather than this, change score, and we add it 100. And at the same time, what I want to do is in our player movement, where do we move? Move position, no, that's strafe. This one, And this one is going to be our forward move. What's forward move? No, our speed. That's what we want. Speed is a float. So what we want? No, don't want to do that. We want to do. Well, I suppose it's C sharp. Round floats. Float to int. Round speed. I'm guessing we need to have a using math somewhere. Oh. Int dot. Oh, can we just cast to an int? That might be easier. We just do int. Ah, nice. So hopefully our score goes up as
directly adding to the score,
based on our speed.
Which adds to the score and also sets the UI. Now we can finally go back to the editor, and in the game manager, we'll assign the score text to the score text variable. I'm going to.
Okay. Going back here. The game manager script score text is this score text.
Hover over the game view and hit shift space to maximize it, then start the game. You can see the score text in the top left corner increasing.
Let's have a little look. Okay, too much that it's getting that, but oh, we're not even collecting coins anymore. What are we broken? When you read input using the switch act and handling. On our event system, what's that? But the change here, that's fine, I think. I think that's all fine as well. Get rid of that. Right, that's fine. That's okay. New input. Then the input module will not work. Okay. Don't really know what that was. What that did. Is it fixed it now? Just replacing that. So the score was way too much, but we'll figure that out in a second. We're not colliding with our objects anymore though. With our coins. Let's pause this. Right, in terms of player movement, this is going to be speed over like 100, maybe even 1,000. Let's do that.
Every time we collect a coin. That's great. Also, if we hit an obstacle and die, when the game restarts, our score will be reset to 0. If you couldn't understand everything that was happening, if I changed it to top right, you can see that it moves wherever I put it. Plus plus is a quick way of saying...
So really, it's our collider that's the issue, right? So in our coin script, I think we're going to be looking at
add 1 to the variable score. Now in the editor, I'm going to exit out of the coin prefab and create a new empty game object, which I'll call game manager. I'll add the game manager script to it, and you can see the score variable here. So as we collect coins, you should see that increase. I'll also right click and go UI text. I'll call this the score text. In the inspector, I'll set its text to say score, colon, 0. I'll also set its font size to 25. This, I'll simply double click on the
that's not what we want.
and scroll to the bottom and add a rigid body component. In here, I'll check is kinematic, which simply means
Double check on our prefab coin. Is kinematic, yeah.
means to ignore regular physics such as gravity, which we don't want. Now we should be able to test it out and see that it's all working. You can see that there's no coins spawning inside obstacles anywhere. That's great. The last
Okay.
you can see that some coins are being spawned by our script. And this is a simple fix. So let's go back to the ground tile script. And in the spawn coins function, I'll set rotation and scale. So we'll say dot position to get its position, and then we'll set this equal to get random point in collider. And for the collider, we'll say get component in angular brackets collider, and finish off with parentheses. What we are doing here is setting the position of the coin that we just spawned equal to a random point in the ground tile's collider. If I go back to the editor, I'm in the ground tile here. If I select the ground tile, the green outline is the collider, and you can see that this only so spawn coins. Now we should be able to test it. So if we save our script and go back to the editor, in the inspector, make sure you assign the coin to the coin prefab variable, and now we should be able to hit play. The coins are spawning now, that's great, and we can also collect them, but nothing happens when we collect them. Additionally, if I pause the game by hitting Shift Control P, and then go back to the scene view, you'll see coins to the coin prefab variable.
So why are we collecting them now?
I'll call the function that we just made, so I'm in the ground tile here. If I select, and for the collider, we'll say get component in angular brackets collider.
Do we have to remap something? So in our ground tile, no, we got our coin prefab there. Obstacle's fine. Our coin capture trigger, yeah, that's fine.
And finish off with parentheses. What we are doing here is setting the position of the coin that we just spawned equal to a random point in the ground tile's collider. If I go back to the editor, I'm in the ground tile here. If I select the ground tile, the green outline is the collider, and you can see that this only extends as far as the ground does. This means that the coins will always respawn within the ground where the player can reach them, and never just out in empty space, for example somewhere over here. Back in the script, in the start function of the ground tile, I'll call the function that we just made, so spawn coins. Now we should be able to test it, so if we save our script and go back to the editor, in the inspector, make sure you assign the coin to the coin prefab variable, and now we should be able to hit play. The coins are spawning now, that's great, and we can also collect them, but nothing happens when we collect them. Additionally, if I pause the game by hitting Shift Control P, and then go back to the scene view, you'll see that all of the coins behind the player aren't being destroyed. Currently this isn't an issue, but if someone managed to get them out of position, I'll create a new function. This is going to be a little more checking whether the item is not the player, not that the item is the player, and what we're going to do is type return in here. This means if the object is not the player, we will stop executing the rest of the function. To destroy the game object, we simply have to type destroy, and then game object with a lowercase g to signify that it's this game object that we're talking about. Destroy destroys object.
Wait.
This game object. Something I believe would be quite a nice visual effect.
We want that at the end. Silly. Because we got rid of it at the start. Right, that should be okay now. And hopefully this score will be going up in a small enough value that we can figure out when we collect the coin. Starting off with 0. Okay, over 1,000 might have been too much, but there's our 100 coin, 200. Okay. Okay, and then we collided. Right. Now, where's our player movement here? Do it over 100 and see if that's any better. Should be getting some little points maybe. Let's see, what was...
To do this,
do we get to the end of the video?
under using Unity Engine, I'll add using Unity Engine.ui. This allows us to access and edit text elements. With this done, we can now add a new public variable, type of text, and I'll call it score text. Let's also add a new public function, so I'll say void increment score. Open and close parentheses and
Wait a minute, why was our controls not working there? Okay, no. Don't know what happened there. The controls weren't hooked up for a second. Right, so we're not getting any score from movement just yet. Maybe over 100 is a bit too much still. I think you want to have score starting straight away. Should start seeing. Actually, no, the speed's gonna have to be way up, isn't it, before we start doing anything? Let's try and look at the speed as we're going. Speed is 21. I think if we're divided by 100, speed's gonna have to be 50 before we actually get any points. So 100 is too much. Maybe just 10. So at the moment it's being rounded down. That's fine. There we go. Right, so it's when you're going over 10. Right. Well, I think that's a good stopping point. Got a few things done today. So we've added in our barriers, our obstacles. we've added in coins, we've added in the score. We've played around with some starting tiles that don't spawn anything, and we have what else do we do? Oh yeah, we varied up how the spawning mechanic works. Added in a game manager, added in our coin, and yeah, been pretty good, I think. Still a lot more to go, but it's starting to be a game that can be playable. Next up is to make a game that is fun to play. So with different changes, I think we'll be looking at ideas of power-ups or status effects or something along those lines. But we will be coming to the end of this tutorial. We're probably not going to be too long into that, into the next stream to finish this off, which at the moment is planned for tomorrow at the same time, so 2 o'clock GMT. And yeah, we'll give it a go. Thanks everyone for lurks and sticking around. Hope you enjoyed it. Hope to see you all again soon. And let's go to that and that and that. And yeah, thanks a lot. See you next time.